the FDP.
Thank you so much, sir.
Entering into the FDP, let me give some. Let me introduce Dr. Maheshwari. For 16 plus years of experience in the field of teaching, especially in mathematics. Interests among the students. She has been elected as a head of a life member of Indian Mathematical Society. Published enormous research papers in international journals. Most of the papers are published with. Her areas of research are in the fields of neural networks, stability analysis, nonlinear and systems. Renowned reviewer for some of the high impact factors like IEEE transactions in neural networks and learning systems. She has various IEEE conferences and was invited to give guest talks. She has collaborated with China, South Korea, and other countries. She was invited to give lecture organizations by the World High-Tech Societies development programs at both national and international level. Dr. Maheshwari received Indians top 50 women for leadership, emerging leader for contribution and achievement in the discipline. Contribution. Wow. For being a part of this program. Sri Vishnu Engineering College for Women. Now its platform is yours.
Thank you, sir. Introduction that you have given me. And yes, I'm so delighted to be a part of this program. As sir had mentioned, and a day to one and all.
Ma'am, we lost you.
Madam, you can mute your video and audio.
Giving a talk on fuzzy logic and neural network. Was 5-day national level online faculty development program on applications of machine learning. And I take this opportunity Management Principal and the head CSE of the Sri Vishnu Engineering College for Women, for giving us this kind of an opportunity, and principal of Kumaragur College of Technology. So, as mentioned earlier, I'm here to share the screen. So, yeah. So, you're able to the screen, so
No, ma'am.
now, sir.
Not yet, madam. Not yet.
Yeah, sure. It has gone out.
Madam, if you much more consumable, madam, so that
Okay, now is it okay, sir?
no, madam, still it is not visible.
Earlier, madam is the having an option for the sharing.
Yes, sir.
Yes, sir. Yes, sir.
Not visible still?
It is still not.
I try to share the entire screen, madam. Say like not the PPT. Try to share the entire screen so that it will be shared to us.
Entire screen, please, sir. Now is it visible, sir?
Yeah.
See, I went to that top.
Oh, madam. Still. Yes. 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 It is coming, madam. Right.
Okay.
Yes, ma'am. We are getting it.
Slowly. Slowly it is. Yes.
Yeah, now it is visible, ma'am.
Thank you. So I approaches for engineering solutions, and fuzzy was invented by ZA at the University of California at Berkeley in the year 1964, and it was in a who had given more insight on this fuzzy logic in a practical application. And logic control, it's the approximate reasoning methodology that exploits the formal models of the common sense reason, much understood as the fuzzy set-based methods for the approximate reasoning at large. So nowadays, everywhere we see this artificial intelligence. So even before dealing with this kind of artificial intelligence and machine learning concepts, which I say fuzzy in terms being a mathematician, I could say they are some of the non-linearities which is found in a particular. When I speak about the fuzzy set theory, it deals with certain phenomenon that will enable us to the thinking, the reasoning, the cognition, and the perception. So as mentioned earlier, being a mathematician, because I have done my research on the neural networks and fuzzy logic, and I'm getting. When I look into that, what I feel is there are a lot of hidden agenda in all these application scenario when it comes to the world. Okay, a system can be a machine or of a product, I can say. The hidden scenario under all these, the product, whether it is the machine, all those theoretical model that we do. Unless and otherwise, a person is 100% sure enough that identifying is feasible, only then it is applicable to release in the society. So where a person is able to say whether a cold or whether the weather is cold or hot. So all these kind of decision happens in the human brain. But actually, when we speak with regard to this fuzzy, it all depends kind of things. So when it is crisp enough, the computer makes certain decisions, but it is not clear and it has got certain dilemma. But when it is very sure enough to say that whatever the kind of the model that it has gone is correct. So for example, in the day-to-day life, not very sure whether how tall he is. Similarly, the temperature being hot, we are not able to, we are not in a position to say how exactly it is she. It all depends upon the kind of the fuzziness that's been involved. Similarly, as mentioned earlier, all these things, same model, it all depends upon the membership functions as far as the fuzzy set is involved, which deals with the binary kind of number, deals with 0 or 1, and fuzzy sets is all being set on the screen, where we deal a dash of x, which is equal to 1 minus a of x, and the intersection, when it comes to intersection, we take only the minimum and we take the maximum value. So why I'm showing it diagrammatically, because any of the things concerning all these on the kind of fuzziness in it, and it is all being represented this way. So here we next we see only now it will move, I think. Depends upon the quality insurance, error diagnostics, the control theory, the pattern recognition, medical analysis, weather forecasting, economics. So these are some of the intensified research that's been happening now. And as mentioned earlier in the previous talk, that machine learning as how it is important. Similar way, this fuzziness and neural networks plays a vital role where you give certain inputs to one kind of a system and you get. When you deal with all these kind of stuffs, what we do is we always deal with the mapping concepts. So I'll just, even before going to says that it is not clear or it is not distinct or it, but after you understand the logic behind the fuzzy, and when we start applying the kind of the Boolean concepts, we say that it is complete of the attainment that we require as per the mathematical model is true or not. Everything is sorted out using this fuzzy. In a sense, I would say that this logic is a logical system where you have a lot of into a more sharp kind of boundaries. So why this fuzzy? Why did this Zeta look into this fuzzy? And it is also descriptive, and we require a lot of logic. These days we see our students when we teach a class. So that should not happen, because logical thinking is very important. So that kind of logic is being applied on the fuzzy in order to capitalize on your positivity. So you can just have a look at this particular diagram where a weight is being lifted on, and the other person, we see that some kind of a weight is just dropped down. So if that particular weight angle, and if he's able to lift it up, is able to know the weight, then maybe it is possible for that through which it is coming down. But if it is coming in a huge speed, definitely he will never be able to do. It is for that particular person to look into the kind of, so you can just have any of the things always has one kind of the input space where all the possible services and the You look into the output space, which comes through some kind of a channel. So in this case, it was all the concepts of deciding the output, and all the output, it all depends upon the basis of the assumptions that we observations, it can be variables, anything of that sort. It is all based upon the problem that we diagram, where hot, what immediately we do is we in the beginning, and later on it increases later on a full speed for some time, and then only we reduce. We are coming, I mean, we are getting inside the room. So what we do is we turn on full regulator after it becomes somewhat in your right side of the diagram, where it says that we set this fan to a very high speed, very low speed after that, and then finally we stop. So what happens when it is too hot? First the temperature is too hot, then slowly is too hot, then again what we do is the room temperature over there, it reduces. So this is what is happening. For an AC room, what happens is all the things are there in the remote. So what happens in the remote is the target, whether it is 25 degrees Celsius that we require. So this is being completely, so the room temperature is being heat or cold, or there is no change. Everything is being set in a thing. So how it works, everything is being fixed in that remote. So there we use this fuzzy logic system. Otherwise, I can also say that it is the control, the decisions that needs to be improvised on that particular system. So nextly, you can just have a look at input. It all determines the measurement or the assessment, or also process the determine needs to be taken. So we need to use if and all the assumptions, whatever we do, need not be right at the first go. So maybe we get a lot of errors. So we need to, and there we determine the center of the mass for all the systems, and finally we get the right kind of signals, and we give the right kind of decisions as well. So whatever I've discussed, the same thing is also shown in this particular diagram as how the fuzzy logic is being implemented. First, as I've told you, you have the crisp input, then you have the scaling. Certain rules. See, always whenever we learn mathematical formulae, we have certain formulae. I mean, puts across those kind of formulae, we say that it is correct or it works. So similarly, fuzzy has got certain rules. And so what happens is soon after that, it goes out to the defuzzification, and then the denormalization is taking place, and that denormalization will enable you to find out that you're getting the right kind of conventional fuzzy to that of the conventional one to that of the fuzzy one. So you can just see the expert system where you have the physical and you also have some kind of knowledge model just coming out. So there is no, any kind of here, but when you look into the fuzzy system, you have a physical device, then you have the fuzzifier, and then you model it, and then and then you get the precise one. Earlier, with regard to the temperature, whatever you have the classical set, you also have the fuzzy set. So in the classical set, you see all the low, medium temperature and the high temperatures at all when you look into this diagram. Whereas when you fuzzify it, what happens is you are able to analyze degrees of freedom. Okay, this is what is this. Okay, this is what is happening at this particular temperature. This is what is the raise. This is what is the, you know, to make certain conclusions. So with regard to the same temperature, we usually keep the temperature 0 to 30 as for low, and so basically when you apply fuzzy, that is what I wanted to tell you, that vague, or sometimes also it becomes smooth. So it all depends upon the kind of inputs that we are giving, the assumptions that we are giving, that all finalizes the final output. So I was discussing, so you can just have a look at this. This is the Boolean way, and this is the multi-logic way. In the Boolean, you get 0 or 1. You may get some kind of the fuzzy kind of, you know, the logic is being applied. So I said fuzzy undergoes certain operations, or it has got certain rules. So for a fuzzy set union, you have the A union kind of functions. In intersection, we deal with the minimum set of functions, and in the complement, we deal with, you know, the membership functions. Exactly equivalent to that of the maximum number from those members in the set, and the intersection operation is the one which do not reside with that of the earlier one. For the fuzzy sets, I always had mentioned earlier also about the linguistic variables, because the variables which we are giving, but it can also be variables, and not what kind of variables, they are all the linguistic variables which we are speaking about. Linguistic variable in terms of the fuzzy mathematical quantities, and these are composed into fuzzy predict. They can be young, smart. Just now I said, no, the girl looks pretty, or the weather is too hot. So these kind of predicates or the modifiers or hedges, you are in a position to find out with certain things, you know, the room is too hot. Hot is all based upon the linguistic kind of variables that we assume for. And a fuzzy model can be obtained by using the methods that includes the evaluating and validating the final models. So you can just have a look at this fuzzy sets that represents the linguistic concepts that allows the low, medium, high, and on one side all the fuzzy sets. And now I just would like to switch myself. Networks is very important when compared to you know, when it comes to the machine learning algorithms. For the neural network, first of all, let me introduce what is biological neural networks. So a neural network by itself, I just would like to tell about our brain structure. You know, or something, our brain has got 1 trillion neurons are connected to each other with regard to some kind of you know, the synapses, which I will be telling. I just would like to tell you that this biological neural network deals with the robustness and the fault tolerance of a system. It can be anything. Okay, so in order to check the robustness or the fault tolerance of that particular system, or the flexibility or the ability to deal with the variety of the data situations, or the collective computation can be easily attained using this neural network concepts. So as mentioned earlier, brain comprises of so many neurons. So each cell works like a simple processor, and between these cells, you know, there are parallel processing. There are parallel processing, you know, the neural network, each and every time we think more, our brain tends to expand actually. You know, we are not aware about it, but that is what is happening. So the more the thinking the brain structure slowly. So a neuron consists, so inside the brain we have so many neurons. So what happens there, you know, a neuron consists of a core, dendrite, the axon and the dendrites, and then so this is the axon and the dendrites which is being. There is something called the axonal behavior, which enables and it carries the impulses. So if anybody touches me, I'm immediately. So how does it happen? So somebody touches me, I don't even know who's touching me, but I know that somebody has touched me. So that brain, and I'm able to sense that somebody has touched me. It all happens through these kind of the axonal movements that happens in the brain. Axon, so which enables or triggers the message, the function through the neurotransmitters. So these neurotransmitters are actually enabled in that, you know, I told you there are so many will have this kind of a structure, and every time, you know what happens, we are not actually aware. Every time these 1 trillion and they burst with each other, whenever they collide with each other, there is a bursting happening. So one thing goes off, again there is an origin. That is all happening through these kind of neurotransmitter, which enables the receptors to stimulate the second neuron. We also find out kind of information from anybody. There is a kind of student you gets marks. What happens is that student is enabled to get only 100 marks beyond threshold value for that particular student. Similarly, when I speak about the temperature, or when I speak about the hot and the thing, just now we were speaking the value. So all these threshold values can be incorporated by using certain activities. Are very, very important for us to know, because these are the activation functions with we have the human brain. So as I've told you, the activation function is very important, and this activation functions will definitely enable our brain to get adapted to it, to learn we need to change dynamically. So you can just have a look at this particular diagram in the artificial neuron. We give the certain kind of inputs, you receive the output. Your comparison of the computer and the biological neural networks based upon the execution of one-step program. And when you compare it, actually what happens is that the cycle time of the neural event, external stimuli, which occurs in a milliseconds range. And when you speak this with respect to the processing, actually what happens is massively parallel operations. So when you speak, computer to that of the biological neural network, what happens? Human information processing for certain tasks. With regard to the size and the complexity, we also it is actually the neurons in the brain is some 10 to the power 11, which comes up to some 1 trillion. So this can also be with our computer, that is the artificial neural network, we can also enhance up to 10 to the power 15. So what I'm trying to our brain does, even the artificial neural network can do. Okay, but at certain points, certain points which is not possible in a computer. So these are some of the negative. So any new information in the same location destroys the old information. So we happen to see that things we must have undergone a lot of instances, but certain instances we never forget. It never fixed, but certain things it just comes and goes and we just tend to forget. So what happens in this particular system is that here, but whereas in our information what we deal with our brain, we just keep only the good ones brain. So these are some of the comparisons that I would like to tell you. And with as I've told you, the information, whatever is being kept in my brain some 10 years ago, whatever preservation actually happens is we are encoding the information. It is all being preserved. So computers are inherently mechanism. There is no central control system for the processing. It acts based upon the information that is available locally. Okay, the information. So you can just have a look, and this is the mathematical are able to etc. N number of variables you're giving it to a function. So this function, I can say that dealing with functions, I will tell you. So, and then finally it gives the output. So the terminology that of the artificial neural network is that in biological neural network, you deal with neurons, the synapses, the synaptic nodes, connections, the weight, and the node output. So here you see is very much similar to that of a biological neural network, where you have a set of values and all these set of etc. xn, and with all the weights w1, w2, etc. wn, and it goes on. See, things, we have two kinds of variables. One is continuous in nature, the other one is discrete. Our world is digitalizing. Every day we are seeing the digitalized world. So in this digitalized world, this discrete system, we always go for summation, and whenever we deal with continuous system, we see for a by the activation function, and finally we get the output. So this input is processed by a propagation funnel incoming, and the resulting value is then compared with that of the threshold values, where you have the neuron activation function. Is you give the set of values, okay, you give the set of values, then you arrange the weights, then it does certain problems. It will undergo certain mathematical functions with regard to the activation functions, and then it gives the output. So these weights that our final result is going to be the feasible one. So that's what the dynamical range of this particular system. It always deals either from -1 to 1, or it ranges from 0. Functions are very complex in nature, but the final end result is going to be a very at the same time it gets activated. And we also see that the alternative is to postulate existence by giving the right kind of the weights. So you can just have a look at this thing where we deal with the function value where y is equal to 2x plus 1. This is the function which I said y is equal to f. Here it is given as y is equal to 2x plus 1. So here the processing, the mathematical function, the one which is correct, by applying the right way of doing the trial and error method. We give this kind of, we see which is adaptable to our particular system, whether it is the step function when we apply this in this particular diagram. Either it ranges from -1 to ensure that it reaches this some of the input values is subtracted from the rest of the others. So these are also having the things, and sigmoid functions are very, 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 very important. So you can just have a look upon the sigmoid curves, where the left one says about the value that lies between 0 and 1, and the right one says about the minus. The curve goes this way. See, whenever we speak about the mathematical, we always say a continuity graph. In continuity, we have got also something called the piecewise continuous function, or piecewise. Instead of this piecewise linear function, it enables us to, find out piecewise means there are continuity. That's what it means. Okay, so here and there it is continuous, but not everything is continuous. So in order to break up all these kind, and also we have something called the step and the ramp functions, which functions, and the piecewise linear functions are more easier for us to compute than the general nonlinear functions. Functions with our which are bell-shaped kind of functions that you can see in the diagram, and it plays a very vital role, because with papers, I've done papers, where you deal with a lot of things. Finally, when it comes to weight, it is all depends. Keep adding the weights. Okay, if this does not tally, I see the matrix form. Okay, if that does not match, again what I do is I come across, and it enables us to publish such kind of good journal publications. I just would like to tell you. So the neural net is propagated layer by layer. From input layer to the output layer, it is something called the hidden layer. So you can just very well look into this diagram, where you have the input values x1, x2, etc., etc. We have the input neuron layer, and we have the weight matrix. These weight matrix will enable you to go to the hidden neuron layer. The number of variables, earlier it was big, now it is being reduced because it is all synced into a few of the variables, and that's what is with the weight that we implement. After the hidden neuron layer, again we make certain changes in the weight, and finally we get the output values. So I would like to tell in one side, but mathematically speaking, there's some kind of topology. When I say topology, so when we deal with these kind of things, there is a space. So all this space is all being done through. You've got two layers. One is called the F1 layer, and the other one is called the F2 layer, which is otherwise called the instar or layer. What happens is that the normalized weight vector Wj is there in the instar, and then where the input vector is presented in the F1 layer. So you can just have a look at this particular diagram, where variables coming from F1 to that of the F2, and the operation of an instar can be viewed as the constant memory. Now, in the case of the out star, you have the jth unit, and here also the signal pattern produces the original input that we are giving. So this is what is happening actually. You can just have a brief look on this particular basics. In star, everything is going to the jth unit, whereas J, again, it is coming out, and then it is releasing its answer. So that's what is the basic structure of the topology with the set of the topology. There's so much of group of instars. It's just not one single instar. There's a group of instars which is happening, taken into consideration. So finally, what happens is there is a bidirectional associative, and it's all being jumbled and mixed out. I told you there is a kind of thing that is happening in the brain every time. Same psychology is happening even in the artificial neural network. So that topology is that it is getting synced up with each of the result. All the supervised and the unsupervised, just earlier I just in telling about, but this I would like to tell you with respect to only mathematical background, where it deals with only the weights between the actual and the desired ones. And in unsupervised, actually what happens is we have no such target. We can adjust too much into weights and all. We just adjust, but we don't look in for the proper feasible solution. So, and we also get the differences in the inputs without any external assistance. So these are the different types of the feed forward or the structure or the learning algorithm. So this is the perceptron model, which deals with the multi-layer architecture, which deals with the multi-layer perceptrons, and they are mostly used in the architecture of neural networks, where you have the input values, then you have the weight matrix, and then you have the output layer, and then you also have in the right side, we also deal with the hidden layer and the weight matrix to output layer. Now here, this is the processing from input layer to hidden layers, and the output layer is called the forward propagation. And so there also we included the sum, the input into weights plus the bias. So bias, so that is what is the weight I'm talking about. So the next layer can be the hidden layer or the output layer, and all these things are. And in the forward propagation, you deal with the variables x, x1, x2. You can just have a look at this particular layer based upon the weights that we do. And finally, we neuron layer, and we get the results as y1, y2, y3. It has the same structure as the multi-layer perceptron algorithm. The same thing holds good. And you can also see the back propagation algorithm. The only difference is that we deal with the supervised learning algorithm. So here also we have the set of input layers, then we have the if it is not giving the desired answer, after applying all the kind of weights, we actually finish up with the answer, no, but desired outcome. Propagation algorithm, the same one which I've just discussed with you. Gradient descent method, which is the iterative approach in order to reduce or minimize the error. And so whenever you get certain errors, because all the time, whatever we do, numerically, we end up of concepts, we introduce this gradient design the slope of the curve using these activation functions. And this has a good look at this particular diagram where you get the right kind of accurate answer. The predictions are all done correctly. So I get some kind of the gradient. So when I say gradient, it's actually the slope. So that's what I've just told you. And we also that affects and which has the minimum solution, and the moment to avoid the local minima, and we can also slow the training of the system. So one iteration or pass through input and update the network's weight is what very much is needed for any kind of the data set. In your words, in mathematical language, we say a system. That's the only difference. And whenever we say bias, you say bias. We since I've been telling you that the weights are always given, and this is the formula for that weight. Y is equal to f of x. Discrete is very important. Okay, so in order to process the neuron, output is equal to sum of weights into the inputs. Be flexible. It is also used for adapt, and some of the limitations are also here. But applications of ANN are huge. It is used in image robo steering and quality assurance. So these are the things. So I've just given a set of which enables you to find out, we are dealing with the gap voltage, pulse on time. All these put together, it goes to the hidden layer, and then you have the output layer, and we are getting the curve, the surface, smoothness, or then you have the material removal rate. So these things are done, and these are some of my research works across to you. So with this, we are developing. So when you look into these e-vehicles, what happens is we need to adopt to some kind of surface. So the surface roughness, when I say, is very important. On what roads can that particular kind of inventions, practical inventions, we are adapting in college, and we are adopting the neural network into that. So with that, I just would like to tell that these are some of the things, and as mathematical modeling. So in mathematical modeling, weights are important. Designing model is very important. When it go to software engineering role. So when a person is very good at modeling, I think he or she should be a great person. So with that, I conclude. Once again, the organizers for giving me this opportunity. Thank you.
Thank you so much, madam. Participants, if you have any doubts, feel free to ask.
Madam, at which places do we use convolutional neural network? We use convolutional neural networks.
On what?
Yes, ma'am. Like,
Question, sir?
yes, ma'am. Like, where should we use CNNs, ma'am?
Basically, we deal with CNN, the neural networks. We do have the feed forward and then feed forward networks. So obviously when it any kind of concepts in the what is that the convolution neural networks, place into consideration. So definitely it is what we deal with. So specifically, if you mention, it all depends upon the problem. So as a lot of high impact factor journals, where I come to know that that or not based upon the system. When I say system, I look into the equations. So there I decide system what we adopt. So that's my question, and I mean, it all depends upon the model, according to me. Yeah.
Okay. Okay.
Yeah, according to me, I'm able to answer that way. So.
Madam, good afternoon.
Yes, sir, please. So,
Some software tools for particular.
yes,
Hello.
fuzzy logic.
Could you please suggest some fuzzy logic software tools? What tools you will suggest?
There are tools, sir, some 2 or 3 tools. As I've told you, more than the fuzzy logic where we deal with the membership functions, and then we deal with all the prefer neural networks than fuzzy logic. Because, and in neural networks, of course, we can use the neural network toolbox, MATLAB. We can also use the direct MATLAB, where when it comes to, you know, modeling, actually what happens is in semi-Markovian and kind of things, we will always put it in MATLAB. And in MATLAB, I use the symbol box, and then only I deal with it. When it comes to the fuzzy controller, usually what I do is that fuzzy